Hello everyone. So we are going to start today transmission line 12. I think I'm audible. Okay. So we are going to start transmission line 12 part. In this section we are going to discuss questions. VSWR question. So in previous class we have discussed VSWR questions. Today also we are going to discuss questions. Okay. So in previous class I have given some homework, one homework, and that question is very beautiful. I think you have done. So this is the question I have given to the homework. Okay. So what is the question? They have asked in this diagram. Reflection coefficient, VSWR, input impedance, everything they have asked. So in this question they have asked everything. So first of all I will discuss input impedance, then after I will calculate the reflection coefficient. Okay. So first of all I will calculate input impedance, then after I will calculate a reflection coefficient. Okay. So this is input impedance. So we have input impedance, two input impedance, one input impedance here, one input impedance here, and one input impedance here. So there is three input impedance. Okay. Then after there is a input impedance at this point also. That means the both two one have. So first of all, what is the input impedance for this one? For this one it is a short circuit, and for this one it is a match condition. So what is the input impedance for this one? So first one is Zin1. Zin1 is short circuited. Zin1 is short circuited. So J Z0 tan beta L, and Z0 is how much? 100 ohm. So J Z0 tan beta L. I will take Z01, so it is tan beta L, and L is here lambda by 8. L is here lambda by 8. So what will be the value? J Z0 is 100 ohm, tan beta is tan beta L, so it will be tan pi by 4. It will be tan pi by 4. I will make this one somewhat little. Okay. So Zin1 is equal to J Z0 1 tan beta L. Beta is 2 pi by lambda, L is lambda by 8, so tan pi by 4. So it will be J Z0 tan beta L. I will write first of all J Z0 tan beta L, and here length is lambda by 8. Z01 is 100 ohm, and tan beta is 2 pi by lambda into lambda by 4, 8. So lambda by 8 and lambda by 2, so Zin1 will be J100 tan pi by 4, and tan pi by 4 is or J100 1, so it is J100. Okay. So this is Zin1. In case of Zin2, Zin2 is at Zin2 length is lambda by 4, so Z0 2 square upon ZL2. Z0 2 square upon ZL2. So this is the one is Z02. This one is Z01 and this one is ZL2. So at lambda by 4, Z02 square upon ZL2. Z02 is how much? 50. So 50 whole square divided by 50, it is 50 ohm. It is 50 ohm. Then after we have Z in 3. Z in 3 is series combination of these two. So Z in 3 will be series combination of Z in 1 and Z in 2. Z in 3 will be series combination of Z in 1 and Z in 2. Z in 1 is J100 and Z in 2 is 50. So 50 plus 1 plus J100, 1 plus J2. So this is the value of our Z in 3. Then after there will be a Z03 value. Z03. So what will be the value of Zin? So Zin will be at lambda by 2, it will be equal to ZL, and ZL is how much? Zin3. So at lambda by 2, Zin will be equal to ZL. So at lambda by 2, Zin is equal to ZL. So it will be at lambda by 2, what it will be? It will be ZL, and ZL is Zin3. So it will be Zin3. So 51 plus J2 is the input impedance. So we have calculated the input impedance for all cases. What cases? Z01, Z in 1, Z in 2, and the combination of Z in 1, Z in 2, and then after input impedance. Since it is lambda by 8, so it will be JZ0 tan beta L. L is lambda by 8. So I will calculate the value of Z in 1. Since it is lambda by 4, so Z0 square upon ZL, and since it is lambda by 2, so it will be Zin is equal to ZL. So Zin is equal to ZL. So I have applied JZ0 tan beta L, Z0 square upon ZL, and Zin is equal to ZL. Okay. Then after we have to calculate the reflection coefficient. What we have to calculate? A reflection coefficient. So I will calculate a reflection coefficient in all cases. So what is the value of reflection coefficient? What is the value of reflection coefficient? I have to calculate that one. So first of all, I have to calculate gamma 1, gamma 2, gamma 3, gamma 4. Gamma 1 is at short circuit, at lambda by 8 from short circuit, at gamma 3 at lambda by 4 from ZL2, and at lambda by 2 from ZL, so Zin 3. So this one is Zin 3. Yes sir. So we have first of all, I will calculate the, you have to concentrate on the formula first. So this is the first one. First one is gamma 1. First one is gamma 1. I will make this diagram little bit smaller. So first one is gamma 1. What is gamma 1? So gamma 1 is nothing but this naught is Z01, this one is Z02, this one is ZL2, and this one is Zin3, this one is Z03, and this one is Zin. Okay. So first of all, I will take gamma 1. So gamma 1 is equal to gamma 1 is equal to ZL1 minus Z01, ZL1 minus Z01 divided by ZL1 plus Z01. So here ZL1 is short circuit, so short circuit. Z01 is 100, ZL1 is short circuit, Z01 is 100, it is minus 1. Second one is our some Zin1 at this position. So what is gamma 2? So gamma 2 will be Zin1 minus Z01, Zin1 plus Z01, Zin1 minus Z01 divided by Zin1 plus Z01. Yes sir. What is Zin1? So Zin1 is J100, Z01 is 100, Z in 1 is J100 and Z01 is 100. So how much it will be? It will be minus 1 plus J and 1 plus J. So you know the which one? Complex number. So this one is the in second quadrant, this one is in first quadrant. The magnitude will be root 2. Angle will be e to the power, first one is 3 pi by 4 and for second one is e to the power pi by 4. So our answer will be e to the power pi by 2. Root 2 will be cancel out. E to the power pi by 2 is cos pi by 2 plus j sin pi by 2. Cos pi by 2 plus j sin pi by 2. So you will get j. Or you can solve it by applying conjugate theory, applying the conjugate multiplication. So in top and bottom you will apply conjugate multiplication and you get j. Then after second one you can solve like this also. So gamma 2 you can solve this like this also. How? Gamma 1 at a distance, how much? 2 beta, distance is lambda by 8. So it will be gamma 1 is minus 1 e to the power minus j 4 pi by lambda into lambda by 8. So it will be pi by 2. So it will be minus 1. So minus e to the power minus j pi by 2. So minus pi by 2 it will be. So it will be minus and it will be cos pi by 2 minus j sin pi by 2. So cos pi by 2 is 0, sin pi by 2 is 1. So it will be plus j. So we can calculate gamma 2 like this also. So gamma 1 we have calculated, gamma 2 we have calculated. Now we will calculate gamma 3. So for gamma 3, what is the formula for gamma 3? Let's see. So fourth one is gamma 3. Gamma 3 is ZL2 minus Z02 divided by ZL2 plus Z02. Yes sir. ZL2 is how much? 50 and Z02 is 50. So 50 minus 50, it will be 50 plus 50, it will be 0. So reflection coefficient will be 0. Fifth one you can apply gamma 3 and gamma 4. For gamma 4 there is Z in 2. So gamma 4 you can apply the formula Z in 2 minus Z02 divided by Z in 2 plus Z02. So how much it will be? Z in 2 is 50 and Z0 is also 50. So 50 minus 50 upon 50 plus 50, it will be 0. There is another method also, sixth method, that you will calculate sixth one, that is gamma 4. So gamma 4 is equal to gamma 3 at a distance, how much? 2 beta and distance is lambda by 4. So it is lambda by 4 distance. Gamma 3 is 0 e to the power 4 pi by lambda into lambda by 4. 4 pi by lambda into lambda by 4. So it will be 0 e to the power minus j pi, it is equal to 0. So it is 0. So our answer will be 0. So gamma 3 we have calculated, gamma 4 we have calculated. Now we have gamma 5 and gamma 6. Now you can calculate gamma 5 and gamma 6. That means seventh one is gamma 5. For gamma 5, Z in 3 minus Z03, Z in 3 plus Z03. So Z in 3 minus Z03 divided by Z in 3 plus Z03. What will be the Z in 3 will be 50, 1 plus J2 and Z03 is 200. It will be 200 and 50, 1 plus J2 and it will be 200. So how much it will be? It will be Z0 2, so 50 minus 150, so J100 minus 150 plus J100 divided by J100 250 plus J100, 250 plus J100, it will be minus 3 plus J2 and 5 plus J2. So its magnitude will be, magnitude you can calculate, so you will calculate gamma 5, you can calculate gamma 5. Then after gamma 6 will be e to the power, gamma 6 will be Zn minus Z0 3, Zn plus Z0 3, so Zn minus Z0 3 divided by Zn plus Z0 3. So this is the question. So Zn is how much? Zn is 50, 1 plus J2 and minus 200 divided by 50 plus 1 plus J2. So what will be the answer? The answer will be same, that is minus 3 plus J2 divided by 5 plus J2. Second one is gamma 6. You can calculate like this also. Gamma 5 at a distance 2 beta, length is lambda by 2. How much it will be? Gamma 5 is how much? So gamma 5 I will write e to the power minus j 4 pi by lambda into lambda by 2 into lambda by 2. So it will be gamma 5 e to the power minus j 2 pi. J 2 pi is cos 2 pi is 1, sin 2 pi is 0. So it is gamma 5. It is gamma 5. And gamma 5 is how much? Minus 3 plus J2 divided by 5 plus J2. So this is the formula for reflection coefficient. So we have calculated reflection coefficient also. So we have calculated everything, reflection coefficient, and then after we will calculate VSWR. Then after we will calculate VSWR. Then after we will calculate VSWR. What is VSWR here? So we will calculate after that VSWR. What is VSWR? So first one is VSWR 1. First one is VSWR 1. VSWR 1 is how much? 1 plus mod gamma 1 divided by 1 minus mod gamma 1. 1 plus mod gamma is 1 is, mod gamma 1 is how much? It is minus 1. So minus 1 into something. So I will write it down. So gamma for value, gamma 1 is minus 1, gamma 2 is j, and gamma 3 is 0, gamma 4 is 0, gamma 5 and gamma 6 is minus 3 plus j2 divided by 5 plus j2. This is the value of reflection coefficient. So VSWR 1 is how much? VSWR 1 is 1 plus mod gamma 1. Mod gamma 1 is our minus 1 divided by 1 plus minus 1. 1 minus 1. How much it will be? It will be 2. It will be 2 divided by 0. It will be infinite. Then we have VSWR. We will calculate VSWR 1. How? 1 plus mod gamma 2 divided by 1 minus mod gamma 2. How much it will be? 1 plus mod j divided by 1 minus mod j. So mod j is 1. So 1 plus 1, 1 minus 1, it is infinite. Then we have third case. Third case is what? We have 50 ohm. So Z in gamma 4. VSWR 2. VSWR 2 is how much? VSWR 2 is how much? So it will be 1 plus, third case I will calculate. So this one is third case. Yes sir. So third case is VSWR 2 I will write it here also. So third case is VSWR 2. VSWR 2 is 1 plus mod gamma 4, 1 minus mod gamma 4. Or you can write it down 1 plus mod gamma 3, 1 minus mod gamma 3. So gamma 4 and gamma 3 is 0. So it will be 1 plus 0, 1 minus 0, it will be 0, 1. Then after we have VSWR 3. VSWR 3. How much it will be? 1 plus gamma mod gamma 5, 1 plus mod gamma 6. So I will calculate it in the next page. So VSWR 3 is VSWR 3 is VSWR 3 is how much? So it will be 1 plus mod gamma 5 and 1 minus mod gamma 5. So how much it will be? 1 plus mod gamma 5 and 1 plus gamma 6, 1 minus mod gamma 6. So how much it will be? Mod gamma 5 is, mod gamma 5 is 9 4s are 13 and 29, 13 upon 29. So 1 plus under root 13 upon 29, 1 minus under root 13 upon 29. So how much it will be? Under root 29 minus 30, 29 plus 13 and under root 29 minus 13. You can calculate the value. You can calculate the value. How much it will be? How much it will be? So 29 under root 5 point, so it is 5.385 plus 3.6, 5.385 and 3.6. So it will be 538, 8.985 and 3.6. So 5 1 and 13 6 7 8 5. So 8.985 divided by 1.785, it will be 5. It will be 5.033. So it is around 5. So it is around 5. So we have calculated everything about this question. We have calculated everything about this question. So what we have calculated? We have calculated reflection coefficient, we have calculated input impedance, we have calculated everything. So this is the answer for everything. First one is reflection coefficient, so reflection coefficient answer. Second one is input impedance, Zin1 is J100, Zin2 is 50 ohm and Zin3 and Zin is our 51 plus J2 ohm. Then we have calculated VSWR. VSWR1 is infinite, completely mismatching. VSWR2 is 1, completely matching, and VSWR3 is 5, so mismatching. So we have calculated all the value. You can calculate by yourself also. It is a very good question because Z0 is different for different cases. Here Z0 is 100, here Z0 is 50, here Z0 is 200. So in this case I will apply Z0 then we are apply ZL1 upon Z01, ZL1 minus Z01 and ZL1 plus Z01. Here I will apply Z1 minus Z01 and Z1 plus Z01, ZL2 minus Z02, ZL2 plus Z02, Zn2 minus Z02, Zn2 plus Z02, and here Zn3 minus Z03, Zn3 plus Z03, and Zn minus Z03, Zn plus Z03. So you will apply the reflection coefficient formula. Then after you can analyze like this also. For input impedance you will take Z0 100, for this input impedance you will take Z0 50, and for this input impedance you will take Z0 200. So it is a very good question if they will ask in the GATE exam. It is a very good question. Then after I will go for next part, VSWR question of other part, other VSWR question, other type of VSWR question. Okay. So this is the first question which I am going to ask. What if a pure, this is the first question which I am going to ask. If a pure resistive load when connected to a lossless 70 ohm line produces a VSWR3 on the line, then the load impedance can only be 25 ohm. True or false? So how much it has VSWR? So VSWR is 3. VSWR is 3. How much it has? VSWR 3, and the load impedance is they are asking. Z0 they have given, Z0 they have given 75 ohm. Then if VSWR is 3, then there is two cases. That means Vmax at load. If Vmax at load, then what will happen? And if Vmin at load, then what will happen? So if they have Vmax, what will happen? If they have Vmin, what will happen? If Vmax at load, ZL is greater than Z0. If Vmin at load, ZL is less than Z0. So VSWR will be, since ZL is greater, so ZL upon Z0. Since ZL is lesser, so Z0 upon ZL. So this is the formula for VSWR. If ZL is greater, so ZL upon Z0, ZL is smaller, Z0 upon ZL. Then VSWR is given 3, so here Z0 is 3Z0, so ZL is 3Z0, so 225 ohm. And for this case ZL is 3, so ZL is equal to Z0 by 3, so it will be how much? 25 ohm. So there is two possibility that it will be 225 ohm or 25 ohm, or they are saying only 225 ohm. So it is a false statement. So our answer is false, because the voltage maximum, if voltage maximum at load, then it will be different. If voltage maximum at voltage minima at load, then it will be different. They have given only in case of voltage minima, so it is wrong. If they have given voltage minima and voltage maxima both, then it will be correct. Second question is like this only. You can pause the video and solve this question. It is also a very good question. So what is the question? Question is, this one is question number 7. This one is question number 8. So in this question, a 70 ohm transmission line, two resistive load R1 and R2. If they have R1, they have some VSWR. They have R2, they have sub SWR. They are asking what is the value of R1 and R2. Because the SWR is same, so they have same VSWR. So I will take VSWR. VSWR is equal to rho. So if they have Vmax at load and Vmax at load, so I will take Vmax at load, and the formula will be VSWR will be, so ZL is greater than Z0. Vmax at load. And here you can see the R1 is taken as larger value, R1 is taken as larger value in all cases, and R2 is taken as a smaller value. In some cases they have taken larger value also. So I will take some larger and a smaller value both, and then after we will solve. So I will say, I will take VSWR is rho, VSWR is rho, and there is some question Vmax. So Vmax at load, then what will happen? So Vmax at load, I will take R1 is greater than Z0. So in this case VSWR is R1 by Z0, R1 by Z0. Then Vmin at load, Vmin at load, that means there is R2, and R2 is less than Z0 I will take, because VSWR is same. So there will be two cases. First case is R1 greater than Z0, and second case is R2 less than Z0, so Z0 upon R2. Then what we will do, because VSWR is same, yes sir, so VSWR is same, so I will say R1 upon Z0 and R2 upon Z0 upon R2, they are same. So R1 into R2 will be, R1 into R2 will be, so R1 into R2 will be Z0 square, yes sir, R1 into R2 will be Z0 square. So I will check which one is the correct answer. I will check which one is the correct answer. So Z0 is how much? 75 ohm. Okay. So R1 into R2, in this case R1 into R2 is 250 and second one is 200. So 250 into 200, how much it will be? It will be 5, 20, 50 and 30, so 50,000. 50,000, which is not equal to 7,500. So it will be not equal to 75 square. 75 square is 75 into 75, 5625. 5625. It is not equal to 5625 or 75 square. It is not equal to 75 square. So this option is wrong, because R1 into R2 is equal to Z square. We have to check. Then we have second case is 225 into 25. 225 into 25. So R1 into R2, 225 into 25. Yes sir. So it will be 75 whole square. So it is correct. In this case 100 into 150. 100 into 150. So 100 into 150 is 100, 150. It will be 15,000. So 15,000 is not equal to 75 square. So this one is also wrong. Then we have 50 and 125. So 50 and 125. So 50 into 125. 6250. It is not equal to 75 square. So this one is also wrong. So our answer will be only B. B option is correct. B option is correct, because in this case VSWR will be same. Or you can solve like this also. 75 ohm, 225 by 75, 200 by 75. Both have different VSWR. In this case 225 by 75, 3. 75 by 25, 3. So it is 3 VSWR. I will divide 100 by 75. It will not be 150 by 75. They have different. And 50 by 75, 75 by 50 and 125 by 50. It may have same value. So we cannot judge. So we can judge only by that. We can solve and then judge, make it VSWR equal. Or I can solve like this also. I can solve like this also. So we can solve like this also. It is a very easy point. By option wise you can go through. By option wise you can go through. So first option is how much? First option is, in case of first one is 250. So VSWR is 250 upon 75. Yes sir. And VSWR 2 is 200 by 75. so it will be not equal. So they are not equal, so this one is wrong. For this one, VSWR1 is for this one 225 by 75, because 225 is greater than 75, and VSWR2 is 75 by 25. So both have same VSWR, so it is correct. 100 by 75 and 150 by 75, so their VSWR is not equal, so this one is also wrong. So VSWR2 is 150 by 75. VSWR1 and VSWR2 are different. Then we have 50 and 125. So VSWR1 is 75 by 50, 2 by 3, 75 by 50, 2 by 3, and VSWR2 is our 125. So 125 by 75, so it will be 5 by 3. So 2 by 3 and 5 by 3 are not equal, so VSWR are not equal. So only one cases we have equal value, that means B option. Okay. Then we have this question number 9. Question number 9. What we have? Question number 9. What we have? They are asking voltage standing wave ratio they have given, and they are asking load impedance. So first of all, I will check how much it has by Vmax. So you will say Vmax is equal to 4 volt. And how much it has Vmin? So Vmin is equal to 1 volt. Yes sir. So what is VSWR? VSWR is Vmax upon Vmin. Vmax is 4, Vmin is 1, so VSWR is 4. Then VSWR is 4, then we have Vmin at load. At load there is Vmin. So at load there is Vmin. So Vmin at load, that means ZL is less than Z0. That means ZL is less than Z0. That means VSWR is equal to Z0 upon ZL, greater one or upon smaller one, so is equal to 4. So ZL is equal to Z0 upon 4. Z0 is how much? 50. 50 divided by 4 is 12.5 ohm. 12.5 ohm. Next, by option wise we can also go. 50 ohm, there is no VSWR, so this option is wrong. 200 ohm, Vmax at load, so this option is wrong. 0 ohm, V minimum at 0, so this is also wrong. So in this case there is neither maxima neither minima, so this option is wrong. In this case ZL is greater than Z0, so Vmax should be Vmax at load, so this one is wrong. And 0, so here in this case the load voltage should be 0. At load the voltage should be 0. So for 0 ohm, load voltage should be 0. So D option is also wrong. So we have only one option, that means C option. Then next question, link type question. In this question what they have asked? In this question they have asked the value. What value? They have asked reflection coefficient. They have asked reflection coefficient. So what is the value of reflection coefficient? So reflection coefficient is equal to ZL minus Z0, ZL plus Z0. ZL we have calculated. How much it will be? ZL is 12.5 minus 50 divided by 12.5 plus 50. So it will be how much? Minus 37.5 divided by 62.5. Divided by 62.5. So 12.5 minus 3 and 12.5 into 5. So 5. So it will be minus 0.6. So answer will be minus 0.6. A is the option. Since ZL is less than Z0, so reflection coefficient will be negative. So this option is correct. This option is wrong. This option is for short circuit and this option is for match load. So this option is wrong. This option is wrong. This option is wrong. So only one option, that means A option is correct. So you can go through like this also. Then we have this question, I will do it later in the next class. This question and this question I will do it next class. Then they have what they have said. They have said a measure. क्या बोला है? They have said, they have given the question, a measure. Question number 11. They have said a measure of 12 mismatch, a measure of mismatch between maximum and minimum voltage current variation along the transmission line is called as SWR, standing wave ratio. SWR indicate how much power is delivered to the load and how much power lost in the line. When SWR is 1, the percentage of reflected power will be 0. When SWR is equal to 1.5, the percentage of reflected power they are asking. So first of all, what is PR upon PI? We will study in where? In electromagnetic wave. We will study in electromagnetic wave. That means PR upon PI should be gamma square. PR upon PI should be gamma square. They have given SWR is equal to 1. So that means 1 plus mod gamma, 1 minus mod gamma. That means mod gamma will be 0. Mod gamma 1 will be 0. That means our PR upon PI, PR1 upon PI will be 0. So it will be PR1 will be 0. So PR1 will be 0. So we can say that PR1 would be 0. Yes, sir. Then after second case SWR is given. How much it is given? So SWR2 is 1.5. So it will be 1 plus mod gamma 2, 1 minus mod gamma 2. So our mod gamma 2 will be how much? You can solve it 1 plus 1 minus 1.5 and 0.5 and divide by 1 plus 0.5. So 0.5, 1 by 5, 0.2. It will be 0.2 and 0.2. So power PR upon PI will be 0.2 square. So 0.2 square is 0.04. 0.04 is how much? 4%. 0.04 is 4%. So our answer will be A. This formula you will study in which part? Electromagnetic wave in normal incidence. Okay. Then after we have question number 12. What is question number 12? So question number 12, you have a 75 ohm transmission line is terminated by a load to 120 plus J80, the maximum and minimum impedance over the line nearly. So they are asking maximum impedance and minimum impedance. So what is the value of Z0? Z0 is 75 ohm. And what is the value of ZL? ZL is 120 plus J80. Yes, sir. So you can calculate gamma L. Gamma L is ZL minus Z0, ZL plus Z0. Yes, sir. So ZL minus Z0, 120 plus J80 minus 75, and ZL plus Z0, 120 plus J80 plus 75. So this type of question is asked in GATE exam, and I have solved this in previous in the paid classes. This question I have solved in the previous year paid classes, and this type of question is asked in the GATE exam 2024. So this is a simply matched question. I have taken ZL complex. In the GATE exam it has taken only simple value. So it is very easy question. It was very easy question. Okay. Then after, what is the value? So it will be 75 and 75. So it will be 45 plus J80, and next one is 75 plus 120, 195 plus J80. Yes, sir. So gamma L will be 9 plus J16, and then after 5 4s are and 5 3s are 15 and 45, 5 9s are 45 plus J16. So magnitude of gamma L will be under root under root how much 16 square plus 9 square divided by 16 square plus 9 square, 16 not 39 square, so 16 square plus 39 square. So this is the magnitude. You can calculate easily the magnitude of gamma L. You can calculate easily the magnitude of gamma L. What is the magnitude of gamma L for this case? For this case, the magnitude of gamma L is, the magnitude of gamma L is 16 square 256 plus 81 plus 81. It will be 337 and 39 square 39 square, so 39 into 39 1521 plus 256, it will be 177 and under root, so 337 divided by 1777, it will be something, under root is 0.5435, so I will take 0.44. I will take magnitude of gamma L 0.44. Then I will calculate VSWR. 1 plus 0.44 divided by 1 minus 0.44. So how much it will be? 1 plus 0.44 and 1 minus 0.44. So 1.44 divided by minus 0.44. So it will be 0.56. So 2.57. Then after we'll go for next part, that means Z max. So VSWR is equal to Z max upon Z naught, and VSWR is equal to Z naught upon Z min. This is the formula for Z max and Z min. So VSWR is how much? 2.57. So it is 2.57. Z max we don't know. Z naught we know. It is 75 ohm. So Z max is equal to 75 into 2.57 into 2.57. So 75 into 2.57. It will be 192.75. Yes sir. And for Z min, what you will do? For Z min, I will calculate again. So Z min is how much? So it will be 2.57. So Z min is how much? Z naught upon Z naught is 75 upon 2.57. So 75 upon 2.57. 75 divided by 2.57. It will be 29 ohm. It will be 29 ohm. So we have calculated Z max. We have calculated Z min. So 192. So 195 approximately. 29 and 28 approximately. So we can take approximate value. So 190 it's okay. At 28 it's okay. So maximum and minimum they have asked. So B option is correct. B option is correct. It is a very easy question. You can calculate very easily. Next question is question number is what? 13. Question number 13. What we have question number 13? I will do 15 question. So a transmission line of characteristic impedance 50 ohm is terminated in a load impedance ZL. The VSWR of line is measured at 5 and the first of the voltage maximum observed at a distance lambda of by 4 from the load. Okay. So they have given Z naught. How much it will be? 50 ohm. It is 50 ohm and terminated by a load impedance ZL. We don't know. in many questions they have asked only ZL. So in many questions they have asked ZL only. VSWR is 5. First voltage maxima. Okay. So first voltage maxima is measured at which point? So at lambda by 4 from the distance load. First voltage maxima is measured at lambda by 4 distance from the load. So here it is maxima, and this is load. This is x is equal to 0. X is equal to 0. So we know that the maxima and minima distance is lambda by 4. Minima and maxima distance is lambda by 4. Maxima and maxima distance is lambda by 2. Minima and minima distance is lambda by 2. So at this point it is maxima. So it is sure at this point it is minima. So we have minima at load, voltage minimum at load. So if we have voltage minimum at load, that means we have VSWR. Yes sir. So we can calculate ZL. So VSWR is equal to 5 and voltage minima at load, V minima at load. V minima at load, that means ZL less than Z0. If ZL less than Z0, VSWR is equal to maxima upon minimum, Z0 upon ZL, and it is equal to 5. So ZL is equal to Z0 upon 5. That means 50 upon 5. It is 10 ohm. It is 10 ohm. So we have calculated ZL also. So ZL is equal to how much? Z0 upon 5, and Z0 upon 5 is 50 upon 5, and 50 upon 5 is 10 ohm. So our answer will be 10 ohm. So it is a very easy question. We have A option. Then we have 14th question. Yes sir. What they have given? They have given in 14th question a twin wire have transmission line. Adjacent voltage maxima is 12.5 centimeter and 27.5 centimeter. And they are asking what? They are asking the value. So we have 3 questions only left. Then after tomorrow we will study some VSWR question topic, and then after we will do some question, and then after VSWR will be over. Okay. So in a twin wire transmission line, the adjacent voltage maxima and minima is 12.5 and 27.5. The operating frequency they are asking. So voltage adjacent maxima and minima they have given. Yes sir. Voltage adjacent maxima and minima they have given. It is a very easy question. So what you will do? Nothing, just simply 0. This one is x. This one is x is equal to load. This one is load. Okay. So we have B max and second one B max, maxima and maxima. First one is 12.5 centimeter and second one is 27.5 centimeter. What is distance between them? So distance between them is lambda by 2. So distance between them is lambda by 2. So lambda by 2 is how much? It will be 15 centimeter. 15 centimeter. So lambda is how much? Lambda is 30 centimeter. So frequency is how much? C0 upon F. If Vp is not given, I will take C0 as a Vp. So 3 into 10 to the power 8 and lambda. So lambda you know 330 centimeter. Lambda you know 30 centimeter. 30 into 10 to the power minus 2. So it will be 10 to the power 9 hertz. That means 1 gigahertz. That means 1 gigahertz. So our answer will be 1 gigahertz. B option is correct. B option is correct. This is very good question. What they have asked? They have asked number of voltage maxima and minima. Number of voltage maxima and minima. So you have to note it down that in your summary also, that this is our load. Yes sir. X is equal to 0 load, and this is our XL. X is equal to L source. Yes sir. So you can read this question, and there is in this bit in between them maxima, minima, maxima, minima, maxima, minima. So maxima, minima will lie in this range only. So x max will lie in this range only, 0 to L, and x minimum will also lie in this range only, so 0 to L. Yes sir. So maxima and minima will lie in this range only. Maxima and minima will lie in this range only. Then I will write it down. What are the values they have given? They have given length is 500 meter. Okay, they have given wavelength is 150 meter, and they have given theta gamma minus 150 degree. So minus 150 degree is how much? Minus 150 degree is minus 150 degree 180 degree into pi, so it will be minus 5 pi by 6. They are asking number of voltage maxima and minima, so I will take number of voltage maxima. I will go for calculation part. We can easily calculate by dividing lambda by 2. So many people do like this. Lambda by 2 is the spacing between maxima and minima is lambda by 2. So if 75 and 50, so 500 upon 75, it will be around 5 point something. So it was 6 point something or 5 point something. So 5. I will divide 150 divided by 75. So 500 divided by 75 divided by 75, it is 6.67. So they will say the number of voltage maxima is 6.67. So it is 7. So it is 7. Answer will be 7. Like that they will give the answer. But that answer is not correct. So we will do that way. In that way you will do nothing mistake. So this one is 0 and this one is x max. If maxima they will ask 0 to L. 0 x max is 2n pi plus theta gamma divided by lambda divided by 4 pi is equal to L. So what we will do, if I will multiply both sides by 2 pi, so it will be 2n pi plus theta gamma into this one is 4 pi L upon lambda. 4 pi L upon lambda. Then we have minus theta gamma 2n pi, and this one is 4 pi L by lambda minus theta gamma. Then we have n will be equal to minus theta gamma divided by 2 pi, and it will be 2 pi divided by that means 2L by lambda minus theta gamma divided by 2 pi. So we have calculated the range of n. So what is theta gamma? Minus 5 pi by 6. So I will put theta gamma minus 5 pi by 6 into divided by 2 pi, and this is n. What is L? L is 500. L is 500 divided by 150, and what is this one? Theta gamma minus 5 pi by 6 divided by 2 pi. So pi will be cancelled out. So it will be 5 by 12 to how much? It will be 5 by 12 to 150. Yes sir. It will be cancelled out. Yes sir. So 100 by 150. So 5, 10, 3. So 10, 20 by 3 plus 5 by 12. So 5 by 12, and it will be 4 times. So 85 by 12. Okay. Then after I will calculate the range in decimal value. So in decimal value what it will be? So 5 by 12, it will be 0.4167, and 85 by 12. 85 divided by 12. So it will be 7.083. Yes sir. 33. So what will be the answer? So value of n will be 1, 2, 3, 4, 5, 6, 7. we cannot take n is equal to 0 because it is in not range, and we cannot take n is equal to 8 because it is not range. So integer value of n will be 1 to 7. So there is 7 maxima. 7 maxima. So number of maxima is 7. 1 to 7. So 7 number of maxima is there. So you can calculate 7. Then we have you can calculate minima also. You can calculate minima also. 1 second. You can calculate minima also, number of minima also. So number of minima is x min to L. So it will be 0 and x min to L 2n plus 1 pi, 2n plus 1 pi plus theta gamma into lambda divided by 4 pi is equal to L. And then after you will calculate 2n plus 1 pi. So 2n plus 1 pi, it will be how much? It will be theta gamma upon pi. Theta gamma upon pi. So it will be something like this. So minus theta gamma plus pi divided by 2 pi and n. This one is 4 pi by L divided by lambda minus theta gamma plus pi and divided by 2 pi. Yes sir. I'll put theta gamma 5 pi by 6, 5 pi by 6 minus 5 pi by 6 plus pi divided by 2 pi and 4 pi by L. So 2 by L, 2 L by lambda, 2L by lambda and minus 5 pi by 6 plus pi divided by 2 pi. So our range will be in this case 5 pi by 6 minus pi by 6, so 1 by 12 n. So minus 1 by 12 and this one is 100 by 150, 20 by 3. So 20 by 3 minus 1 by 12. So it will be minus 1 by 12 and it will be 79 by 3. 79 by 3. So how much it will be? 79 by 3. How much it will be? So 1 by 12 and 79 by 12. N you can calculate. So we can calculate N. So 1 divided by 12, it will be 0.083 and 79 by 12, 79 divided by 12, it will be 6.583. So minus value, so n should be 0, 1, 2, 3, 4, 5, 6, 7, 6, up to 6 only, because 7 is greater than 6.5. So there is 7 minima. There is 7 minima. Yes sir. So number of maxima minima in a transmission line you can calculate easily. This way you can calculate number of maxima. This way you can calculate number of minima. So today we have discussed some question of VSWR. Tomorrow also we will discuss some question of VSWR, and then after we will go through the some points. So tomorrow we will discuss also question of VSWR. So we have discussed some questions today here. We have discussed some question. You can download Unity app. It is very useful app, and then after you can join this Telegram channel Sonu Sir PW. It will be very helpful for you. Thank you. We will meet it again.